Hello and welcome to our lesson on measures of central tendency. Measures of central tendency is basically fancy terminology for average or averages. So if I said to calculate, an average quiz score from your quizzes or an average homework score from your homework assignments, an average is meant to measure a center of a set of data. So when I say find the average quiz score, for example, if you lined all those up and you had to pick one number to represent all of them, you're going to look for something that's sort of in the center. Okay? So that's why averages are also referred to as measures of central tendency, because they tend to measure the center of the data. Okay? Now, when I say average, there are technically four types of averages. There are four ways that we tend to measure the center of the data depending on what kind of data we're looking at. Now, usually when I say average, the one you're probably thinking of is the mean. The mean is the most commonly calculated type of average. And I'm going to explain the differences as to why we need all four of these. But the mean, if I said again, find the average quiz score, that you're probably thinking of mean quiz score, which is where you add up all the data and you divide by how many data pieces there were. So this would be the sum of all of the data pieces divided by how many data pieces there were. Okay, so you add up all 10 quiz scores and divide by 10, or add up all 5 quiz scores and divide by 5. We also have what we call the median. So the median is another way to measure the center, and it is the middle value. It is literally the number that is in the middle when your data pieces are in order, so of an ordered data set. Okay. We also have something called a mode. A mode can measure the center, and the mode is the piece of data that occurs the most. And the mode, it's possible that there isn't a mode. So if you had 5 different pieces of data, all 5 of them are different numbers, then there is no one that occurs more than the other. Or let's say you had 5 numbers, let's say you had a 5, a 2, a 2, and a 3. Well, in this case, these both repeat twice, which is more than the one that you have here. So it's possible that 2 and 5 both represent the mode. So you can have really any number of modes. 0 modes, no mode, 1 mode, 2 modes, 3 modes, however it works in your set of data. So there may be any number of modes. So 0 or 1 or 2 or any number of modes can occur. Okay? And then the last one is one that you might not have heard of before with this set of data or a set of averages. Sometimes it's taught mean, median, mode, and then range, but range is not really a measure of center. But mid-range is our final average, our final measure of center. And this is where you take your highest, lowest values, the sum. So you want to add your highest and lowest values and divide by 2. Okay, so all of these are intended to measure the center of data, but there are cases where one is more appropriate to use than another, and I'm going to distinguish in a few minutes. But first, let's just practice calculating. Okay, so we're going to try to calculate the 4 types of averages for this set of data. So first, to find the mean, we've got to add everything up. So we take the 21 plus the 9, oops, it was 8. And then I'm going to do more work here. Mostly this is going to happen in the calculator, but I just want to make sure you're seeing what's happening. So 21 plus 8 plus 9 plus 21 plus 28 plus 24 plus 11 and 20 and 12 and 25, and then all of that's going to be divided by, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers in that set. So, and if you just want to jump to the calculator, obviously this isn't work you have to show, I just want to make sure my notes are thorough here, okay? So 21 plus 8 plus 9 plus 21 again, and 28 and 24. Oops. Make sure you hit the right buttons. And 11 and 20 and 12 And finally, 25. So we get a total of 179. So 179 divided by 10 is going to give us our mean. And then dividing by 10 just moves the decimal, but so you can see it, that's going to be 17.9. So 17.9 is the mean for this set of data. And then the mode, that's an easy one. Which one occurs the most? Well, all of them are happening one time. All the data pieces happen exactly once except for 21. 21 happens twice, which is more often than any of the other data pieces. So we're going to say our mode is 21. And then the median, to find the median, you're going to find the number that's in the middle after you have put the data in order. So we're going to make a new list for this data in order. So lowest to highest, we have 8, and then 9, and then 11 and 12. So 8, 9, 8, 9, 11, 12, and then 21. Oops, forgot the 20. 21 twice. And then 24, 25, and then 28. And let me just make sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep, got all 10. Okay, so if there's an even amount of data pieces, where is the middle? So in this case, the middle is going to be right here, where we have 1, 2, 3, 4, 5 numbers below, 1, 2, 3, 4, 5 numbers above. So if there is no specific number in the middle, then we have to find the middle of the two numbers in the middle. So what is in the middle of 20 and 21 would be 20.5. And we can find that by taking the 20, adding the 21, and dividing by 2. That's the same thing we did finding the midpoints when we were doing our statistical graphs. So 20.5 is going to be our midpoint. Now if you had a number in the middle, so 1, 2, 3, 4, 5, if there were 5 numbers, for example, if 1 occurs in the middle, there's 2 below, 2 above, then we take the number that's in the middle. But if there isn't a middle, then we have to find that midpoint by adding the 2 next to it and dividing by 2. Okay, so 20.5. And then the last one we're going to look at here is our mid-range. Mid-range is where we add the highest and the lowest and divide by 2. So the highest number in the set was 28. The lowest number in the set was 8. We're going to add those and divide by 2. So we have 36 divided by 2, which makes this 18 for our mid-range. Okay, not super challenging calculations. So just so we can run through again, let's make sure we got a good grasp on this. Mean, we're going to add them all up. So 16, 21, 17, 20, and 18. And then we're going to divide by how many data pieces there are. In this case, there are 1, 2, 3, 4, 5. So I'm going to divide by 5. So calculator says, let's see, 16 and 21 and 17 and 20 and 18 altogether makes 92. So 92 is going to be divided by 5. And let's just put a parenthesis and say divide by 5, and we get 18.4. So 18.4 is the mean for this set of data. The mode is the one that occurs most often. So we actually have no mode in this case. So there is no mode. Now, we technically could say that every one of those numbers represents the mode. So I could say the mode is 16 and 17 and 18 and 20 and 21 because they all occur the same number of times. Or I can say no mode. So either option. And I think no mode is a little easier than stating all of them, so either way. All right, the median requires us to put this data in order. So 16, 17, 18, 20, and 21, and then the median is the one that's in the middle. And this has a middle, right? 18 is exactly in the middle where there's 2 below and 2 above. So we're going to say that this median is 18. And then the last ones are mid-range. That's where we add the highest and lowest and then divide by 2. So the highest is 21, we add the lowest is 16, we divide by 2. So that's going to be 37 divided by 2. And just so I don't goof, let's just calculate it real quick. 27 divided by 2 is going to be 18.5. 18.5. And you can kind of see in the first example, 17, 21, 20, 18, there's a little variety in there of where the center is. But you can see in example 2 how 18.4, 18, 18.5, those are all really close. So depending on the set of data, one number might be better than another for measuring the actual center, okay? So I'm going to talk about why we need 4 different types of averages and the different scenarios in which one might be more appropriate than another. Now, the most commonly calculated average is the mean, and the mean is the one that is used most because it's used when every piece of data is considered or weighed equally. Okay, when everything is considered or weighed equally, to find the average, we generally want to count the mean, because it's the only one that is affected by any change in the data. Okay, so think about this. The mode, for example, if you have a number that occurs 5 times and another one that occurs once and another one that occurs twice, I could throw another number into the data that only occurs once. It's not going to affect the mode, because the one number that occurred 3 times is still occurring 3 times, and the one you just put in there only occurs once, right? Or the middle. If you have the same number that happens 10 times and you put it in there again, it doesn't affect the number that's in the middle. If you have the mid-range, the highest and lowest don't change, but anything in the middle of that changes, it's not going to affect the highest or lowest. The only average that is affected by any change in the data is going to be the mean. And again, this is the one that we want to use when everything's weighed equally. So that's why when we're looking at quiz scores, we generally find the mean for our average, because when you take 5 quizzes that were all worth 100 points, they're all weighted equally. Okay? Now, sometimes you have one or more pieces of data that are much larger or smaller than the rest of the data. So you have these extreme values, and they significantly affect the mean. And in a situation like that, it's going to be better to use the median. So if you have extreme values that could really skew the mean, that's where the median is going to be helpful. So let me show you an example, okay? Let's say you took 5 quizzes. You got, I don't know, an 81, an 87, a 92, a 94, and then you got a 90, okay? If you found the mean for these, let's go ahead and do it. 81 and 87 and 92 and 94, and what was the last one? 90. And let's take all of that and divide by 5, because there were 5 in there, an average of 88.8. Right, 88.8, that sounds pretty reasonable, right? You got a couple B's in there, you got a couple A's in there, so you have a really high B average. Makes sense. So we want to use the mean because each of those quizzes was worth 100 points or 100%, and you get an average that is representative of what you're earning, okay? Now, let's say the 6th quiz, you didn't do it, didn't submit it, and you got a 0, okay? So we're going to put a 6th quiz on here that's a 0. And maybe your next quiz, you turned it in extremely late. And so you got some of the questions right, some of the questions wrong, and then you got a late penalty, and you only scored like a 20 on it. All right? If I add this in here, a 20 and a 0, and then I divide by 7 quizzes now my average is a D average. Okay? Now, are you really a D student? No. This one you just didn't take, and this one was extremely late, but that's not really representative of who you are as a student. This is what's representing who you are as a student. So in a case like this, it might be better to find the median. Okay, if we found the median here, we put these numbers in order, 0, then 20, then 81, then 87, let me move this, 87, and then 90, and then 92, and 94, then the median's going to be right in here, which is still going to be representative of you as a student, okay? So these two outliers, the one that you were absent for and the one that you got a big old late penalty on, right? Those extreme values really weighted down the mean, and so the median is going to be better representation of the actual average, okay? So if you have extreme values, we're going to go with the median instead of the mean. All right, now the mode seems like it'd be a weird one. Why would the mode, or when would the mode be most appropriate? It's going to be helpful in scenarios when the frequency of the data is what we're looking at. Okay, so sometimes the frequency is important. For example, I don't think I need to write this, but I can just talk this one out. For example, let's say you're a home builder, okay? You just bought this big plot of land. You want to start building homes on it, selling the homes, making some money, right? But you also want to make sure that the homes that you're putting on this land are appropriate for the area. You don't want to put on this land that you bought a bunch of 5 and 6 bedroom houses if the people in your area only have 1 to 2 kids on average, right? So maybe you survey, you're collecting statistical data, right? You survey the people in the surrounding area, or you collect information from the census, okay? And you find out that there's an average of 2.1 kids in every home. Well, that average was probably a mean, okay? And I don't know if that's appropriate to build a house that's accommodating 2.1 kids. What does that even look like, right? But you got a list of all the answers from this survey, and there was 1s and 2s and 3s and 0s and 4s and whatever, and the most frequently occurring number on the list was 3. If the most frequently occurring number on the list was 3, that's probably going to be how many kids you want to accommodate in the house that you built. Okay, so there are situations where the mode or the frequency of the data is desirable, right, where a decimal amount might not make any sense. And then the last one, the mid-range. The mid-range is one that's it's probably the quickest other than the mode. It's the quickest that can get to the middle. It's sort of like a shortcut for a mean and a median, and it's one that we're going to use when the data that we're studying is constantly changing. Okay, for example, let's say you're a meteorologist, you're a weather person, you're looking for an average temperature. Well, the temperature is changing all day long, okay? So if your temperature is changing all day long, the quickest way to find the average is going to be take the highest, add the lowest, divide by 2, right? Take your highest and lowest, divide by 2, that's going to put you right in the middle. And that's what the average is supposed to be telling us. It's that measure of that center. Okay, so hopefully that makes a little bit of sense. Now, I'm not going to be asking you questions specifically on, hey, which measure of central tendency should I use in this situation, because some of it will still be up to personal interpretation. I just wanted you to have that understanding. Really, what I need for you to be able to do is make the calculations. And honestly, although these calculations aren't difficult, your calculator can do them for you. So I'm going to show you how to do that. And toward the end of the notes. There's one other thing I want to show you, and it's, again, in analyzing data, we can find measures of central tendency, and we can also break up our data into what we call quartiles or percentiles. So any data can be split into 4 sections, into 4 groups. Just like you can split a dollar into 4 quarters by finding quartiles. Okay. And, by finding medians. Let's go 3 medians. Okay, and each median is called a quartile. Or percentile, because it's going to be a cutoff for a quarter, or 25% percentage of the data. And so here's like a visual, okay? So you have this set of data where there's your lowest value, there's your highest value. So the median that we've already discussed, right in the middle, could cut that data into 2 groups. Well, if you take the lower group and you cut it in half again, then you have another median that you found, but it's the median of that lower half. If you take the upper group and cut that in half again, you found a median again. It's just a median of the upper half. What you've done by finding the 1, 2, 3 medians is you've cut your data into 1, 2, 3, 4 groups. Okay, and each of those groups, the 4 groups, they're called the 4 quartiles. You have 4 quarters of data in there. They're 25% of the data each. All right, so you've got 25% in here, 25% in here, or 50% below that first median, or 25% below that. The second median, 25% below the first median, or you've got 25 here and 25 here, so that's 50% above the median, or you've got 25% above the median of the upper half, and so on. So now that I've messed this up with all kinds of color, if you had to find these medians or these percentiles or these quartiles, you're going to start by putting your data in order. That's how we found the original median, right? You identify your lowest and highest values, or highest and lowest, whatever. And you're going to find the median of the entire set. And that's going to cut it into 2 groups, and you're going to find the median of the entire group, and then you're going to find the median of the lower half, median of the upper half last. Those will be the last 2 that you find, and those are going to be what we call Q1 and Q2. Okay, so let me just try to explain this again. Eraser. Okay, so you have this whole set of data. You're going to put it in order first. So you arrange it in order, and you got your highest and lowest. And then from there, you're going to split it in half by finding this median. So you put it in order, identify the highest and lowest, and then the first median you're going to find is the median of the whole data. And then you're going to find the median of the upper half and the lower halves, second and third. Oops. Second and third. Now, these medians have other names, okay? We're going to call this one quartile 1. We're going to call this median quartile 2. And we're going to call this one quartile 3. This first one is called quartile 1 because it is a cutoff for the first quarter, for 1 quarter of the data. We're going to call this one quartile 2 because it's a cutoff for a median of 2, or for a cutoff for 2 quarters of the information. And this one's called quartile 3 because it's a cutoff for 3 quarters of the information. Okay, so quartile 1 is called quartile 1 because it's a cutoff for 1 quarter of the data. And we can also call it the 25th percentile, again, because it's the cutoff for 25% of the data. Quartile 2 can also be called the 50th percentile because it's the cutoff for 50% of the data. And then quartile 3 we can also call the 75th percentile because it's a cutoff for 70% or 75% of the data. Okay? So we have 25%, 25%, 25%, 25%. There's your 4 quarters. Again, quartile 2, quartile 1, quartile 3. So even though it's 1, 2, 3, like that order makes sense, when we are finding these, I made a mistake here. We want to find quartile 2 first, and then we go back and find 1 and 3. Okay? So let's practice this concept. So we're going to try to calculate the quartiles for this set of data. The first thing we're going to do is put this in order. So we've got 31, 31, 32. I just don't want to miss anything, so I'm going to cross these off as I go. 35, 37, 35, 37, 40, 42, 42. And then lastly 44. So now it's in order. And so now I have my highest, I have my lowest. So here's my lowest value, here's the highest value. And now I want to cut it into 2 groups by finding the median of the entire set. So 1, 2, 3, 4, 5, 6, 7, 8, 9 values. That means there's 1 right in the middle. So that's 4 below and 4 above. That is my quartile 2, also called the median. That is our median of the whole set that's quartile 2. That's the one we find first. And then, now that we've cut that into 2 groups, we're going to find the median of the lower group and the median of the upper group, and that's going to give us our quartile 1 and 3. So what's in the middle of the lower group? Well, there are 4 numbers in this lower group, so the middle is actually here. And what's in the middle of 31 and 32? Well, 31 plus 32 divided by 2. That's going to give us a 31.5. So 31.5. Let's make sure I can fit this in here. 31 plus 32 divided by 2 is 31.5, and that is our quartile 1. Okay? And now we're going to go to the other side. The middle is right here. Well, what's the middle of 42 and 42? There is no middle, which means 42 is going to be it. But if you took 42 and 42 and added them and divided by 2, you're going to get 42 again. So 42 is going to be quartile 3. Okay, so 31.5 is the cutoff for the first quartile, first quarter of information, and 37 is the cutoff for the next quarter of information. 42 is the cutoff for the next quarter of information, and now you have that set into 4 separate groups. Okay? Alright, so that's the calculation part. Not so bad, just finding some medians. And then the quartiles and percentiles, just so you can put some meaning into some other situations. Let's say that Chase, that's my son actually, he's told that he's in the 75th percentile for height as a 9-year-old boy. What does that mean for Chase? So think about your setup here, okay? So you have your shortest students over here, your lowest. You have your tallest students, kids over here. They'd be the highest values. You have the middle. You have the quartile 1, and you have the quartile 3. And the 75th percentile, quartile 3, that's where Chase is at. Chase is right here. Okay, he's at the 75th percentile. He's right there at quartile 3. So if he's right there, what does that mean? Well, if he is right on that marker, that means he's taller than 75% of the other kids his age. And it also means that he's shorter than 25% of the kids his age. So Chase is taller than 75% of 9-year-olds. And it means that he's shorter than 25% of 9-year-olds. Okay, so it just kind of puts into perspective where you are. Pen. Okay, so like, I don't know, if you took the ACT test any kind of recently or ACT test, they'll give you something like, oh, you scored in the, 50th percentile, and sometimes people think, oh, I got a 50% in the test. That's not the same thing. If you scored in the 50th percentile, that means you scored like 50% or higher than 50% of the other people who took the test, right? Or, if you scored in the 30th percentile, you're like, oh, that's really bad. But if you scored in the 30th percentile, you scored better than 30% of people, okay? It's not exactly ideal, but it's just to put things in perspective with everyone else, all right? All right, now some things about your Desmos calculator, your wonderful Desmos calculator. I don't think that calculating any of these things, quartiles, averages, are difficult. But if the calculator could do some of it for us, shouldn't we let it? Right, that's what we have technology for. So I want to show you how to use technology to calculate some of these statistics that we've been calculating. And what we're going to do in Desmos, let me run through the steps and then I'll show you how to do it. You're going to press the plus sign in the upper left-hand corner, and that's going to allow you to add a table to enter in your data. So type the data into the table that we're going to put in, and then you're going to go into a separate line, and you're going to choose functions, or you're going to press functions so that you can choose stats, because that's what we're going to try to calculate. And then you're going to press the one that you want to calculate, and in parentheses, you're going to put in x1, because that's going to correspond with the data. Again, this I'm going to show you in a second. And then for quartiles, you're going to put in x1 and then whatever quartile you're looking for, and it's not going to do mode or mid-range for you, but luckily those are pretty easy to calculate on your own. So let me show you all this stuff that I just said and these steps that make no sense. So when you open up Desmos, you can see that there's a plus sign like right in the middle left of the screen. I'm going to hit that plus sign, and then it gives me the option to enter a table so that I can put data in. Now I don't need the second table or the second column of the table because I only have one list of data. So I'm going to enter the data that I have here. So I'm going to hit 1 and the little blue arrow in the corner to go to the next, which is 10, and then 2, and then 3, and then 10 again, and 8 again, and 5, 11, 9, and 7. Okay, so now I got my data in there. Now, any calculation I make is going to have to be outside of the table, so I need to go and tap into a second line here. If I go to functions and then choose stats, I have some things that I can calculate, like the mean. So if I press mean, it's going to say, what do you want to find the mean of? Well, what this list of numbers is called is x1. So you see at the top of the column it says x1. That's what I need to use. That's like the name of this list of numbers. So here I need to say I want to find the mean of the list that is called x1. So I'm going to type in x1, and it's going to tell me the mean of that list is 6.6. So 6.6. And then the median. Let me go into another line here. Again, I have to go to a separate line to make a separate calculation. Let's go to functions and stats again. Here's my median, so I'm going to hit median. And again, what do I want to find the median of? Well, the list of numbers that we called x1. And it tells me my median is 7.5. And now quartile 1. So let me go to functions again. And be careful because there's a quartile and there's a quantile. Those are different things. Make sure you choose quartile. And now here we got to do two things. I want to find a quartile of list 1, or of x1, the list I called x1, so I need to put that in there, and then a comma, and then I want to tell it which quartile I want. Do I want the first, or the second, or the third? So I'm going to put in 1 for quartile 1, and then I'm going to delete that and put in 2 for quartile 2, and then I'm going to delete the 2, and put in 3 for quartile 3, and it gives me 10. Okay, so just make sure here we're putting in a 1 or a 2 or a 3 depending on which quartile that you want. And there it is, it makes those calculations for us. Now if you had to find them all, it doesn't do the mode, but we can find the mode. Is there one number that occurs more often than the others? Sure. 10. So let's add that to our list. And it doesn't find the mid-range. That's okay, we can find the mid-range. For the mid-range, we're going to add the highest and lowest and divide by 2. So the highest is 11 plus the lowest is 1. If we add those, we get 12, and 12 divided by 2 makes our mid-range 6. Okay, so you have the option. If you want to do calculations by hand, you absolutely can. But if the list of numbers is bigger, like the numbers are bigger, the list is bigger, then feel free to use technology. Okay, you've got some practice, try it out, and as always, if you're struggling, just reach out for some help. Alright guys, take care.